Hey there, welcome to Significantly. Today's video is going to be about variation. Okay, I get it. We're varying, right? That's a very clever bit, but I think I should probably take the video from here. So why don't you... Yeah, all right, okay, good. Okay, so what is variation?
Variation is just when you have a trait that can be expressed in different ways. And so
the different traits that you see in a population.
Variation is pervasive in all of life. If you look at any group of living things, you're gonna find differences. And one of the main challenges of our science is to make sense of those differences. In the last episode, we started to look at a fruit fly experiment. Scientists had noticed some variation in their flies, and they wanted to understand why.
Hey, look, I think this fly is drunk.
Oh yeah, that guy? I wonder if it has anything to do with his sex life.
He is always trying and failing.
So they were in this big lab, like tens of thousands of flies, and they noticed some variation in their population. The flies were having different amounts of sex, and they were also consuming different amounts of alcohol. And the researchers wondered if those variations might be connected somehow. So they designed an experiment.
We divided male fruit flies into two treatment groups. In the first group, the males were placed together with lots of virgin females for 6 hours a day, 4 days in a row. They had a lot of sex. In the second group, males were placed with a single mated female who, since she had already mated, would reject the male's advances. Males were rejected 3 times a day, 4 days in a row. After they experienced either mating or rejection, flies from both groups were given the same choice. They could either consume sugary food, like this green apple, or food that had been supplemented with ethanol.
So they tested a whole bunch of different flies in this experiment, and each fly that they tested responded slightly differently because that's what variation is, right? So I have a question for you. How many flies do you think that you would need to test in order to be really confident that you had observed the full range of responses that the fly population has? Or, like, another way to ask the question would be, as the number of flies that they tested increased, did the range of variation that they saw get larger, or did it get smaller? Like, how does variation relate to sample size?
If you have a larger population and you're sampling many things, you might get more variation because you're just sampling more individuals, I guess.
In a bigger sample size, you'll have more variation. In a smaller sample size, you'll probably have less variation.
If you have too small a sample size, there's going to be a very large variation. If you have a small sample size, you're going to have like a higher variation than if you have a larger sample size, which is more representative of the whole, which will decrease your variation.
If you had a larger sample size, I believe that it would be these smaller variations. You might get more variation because you're just sampling more individuals, I guess.
Okay, so which is it? Does variation increase or decrease with sample size? Well, maybe we're not quite asking the right question. Let's take a look at how they analyzed the
We
experiment.
can depict the preliminary results of the experiment like this. For the sex-deprived males, we can make a table and put a mark indicating whether flies preferred alcoholic or non-alcoholic food more often. This is what that table would look like for the first 20 sex-deprived male flies. From this, it sure looks like the male fruit flies that were deprived of sex prefer alcohol. Many more flies in the alcohol column over here. But how do we know that we've looked at enough flies to make this assumption? See, here's the problem. In the general fruit fly population, there's going to be some natural variation in the way that sex-deprived flies respond to alcohol. Some sex-deprived flies, due to genetic differences, just aren't going to be that attracted to alcohol, while others will be extremely attracted. Most flies will fall somewhere in the middle. We can imagine a curve called a normal distribution, and the shape of the curve tells us that for any population of fruit flies, we can expect that their response to sex deprivation should be distributed, well, somewhat like this, with the majority of flies showing an average attraction to alcohol and a minority showing extreme responses at either end. If we rebuild our table over here, it seems to show that sex-deprived flies chose alcohol a lot, but not all of them. Notice that there are still a few here that chose non-alcoholic food. These are flies that were chosen from this edge of the normal curve. How do they impact our conclusion? Well, in this case, not too much, because we sampled all of these other flies which show a different preference, but the number of flies we're looking at matters. What if, for example, our sample was smaller and we just looked at these flies? With this smaller sample, the results look completely different. It actually looks like the flies had no preference at all. In this case, with such a small sample size, sampling even a few flies with unusual responses makes a big difference in what our results look like. It totally changes them. The takeaway from this is that depending on how we sample, our results can change. But we don't want to just know about how flies in one sample or another behave, we want to know about flies in general. In order to do that, we need to sample a large enough number of flies so that we can be reasonably confident that we sampled flies from everywhere underneath this curve. That way, even though we might sample a few flies with extreme behaviors, we can be pretty confident that an average fly in our sample acts similarly to an average fly in the world.
Okay, so now that we've been through all of that, let's go back to our earlier question. How do you think that variation relates to sample size? Well, a larger sample size won't actually make your variation bigger or smaller, but rather it can give you confidence that you probably really did observe the full range of possibility that's out there in the general population. When your sample size is good, it should reflect the population's shape.
If you have a large enough sample size, a lot of variation is going to be normally distributed, and so you're going to have a bell-shaped curve.
It looks like that. It's like the cobra from Cobra that ate an elephant from Little Prince.
The larger your sample size, the more likely you're going to have some sort of bell-shaped curve.
Much of the variation that exists in the world takes a kind of shape, and it's a shape with properties that can be understood if we look carefully. As we're trying to make sense of the living world around us, it can often be quite helpful to look out for those shapes and patterns that exist there, but that aren't always the easiest to see. That's how we come to know things. Samples vary, but if we choose them well, they will vary consistently, like this, and in so doing, reflect the world around us. So, I asked a bunch of students how variation related to sample size, and I got, a variety of answers, right? It turns out that the relationship between these two ideas isn't as simple as when one gets bigger, the other one gets smaller, or vice versa, or anything like that. It's more nuanced, right? So, now that we've been through the whole video, I want to hear your take. How does variation relate to sample size, and why does that relationship matter? So give it some thought and let me know in the comments and we'll chat. It'll be nice. Okay, I'll see you in the comments. Bye.